Okay, so this one here, before I take the derivative, I'm going to separate it. So I've got ln of x squared plus ln of sine cubed x. This is powers on the argument. This powers on the argument, so both of these will come down. Okay, so now I'm ready to take the derivative. So 2 times 1 over x plus 3 times 1 over sine of x times the derivative of sine cosine. Okay, so let's look at this one. It's got division. So I think I can rewrite that as subtraction. And both of these exponents are on the argument. So let's bring them down. So the derivative would be 2 over secant times the derivative of secant, which is secant tangent, minus the derivative of this, which is 1 over x. Okay, this one here, I want to make sure you do not do bad math, because you know that this does not equal x plus 4, right? That's really bad math. So you say, oh, look at that. I do see that there's an exponent of 1/2 that I could pull down in front, right? And no, you never take, if you have ln of, I'll just say a plus b, you never say it's ln of a plus ln of b. That's another big no-no. So now we're just ready to take the derivative. So the derivative will be carry the 1/2, ln of stuff, put that in the denominator, and then times the derivative of stuff. Okay, question, is this -1, does it come down? Because that looks like it's on the argument, because this is on the inside, but no. When it says tangent to the -1, that is the same as saying arc tangent of x. And the same with sine to the -1. That means arc sine of x. So you cannot bring that number down. So we just get to go take the derivative. So derivative will be 1 over that function times the derivative of this arc tangent. So that's 1 over 1 plus the argument squared, and then I have to multiply by the derivative of this, which we know is -e to the -x. And then I just want to simplify this a little bit, because I've seen people multiply these incorrectly. So this turns out to be 1, let me put it over here, this is way too tight. Okay, so this turns out to be, this one stays the same, e to the -x. Okay, so this here, so I'd have a minus e to the -x, and it'd be 1 plus, and you multiply these exponents, so e to the -2x. Okay, last one here. So before I go dig in, I'm thinking, are there any log properties? Yes. So I could split this up to be ln of x plus ln of y. And I still haven't taken the derivative. And again, do not bring that -1 down, because that has a different meaning than just the power, right? So now I'm ready to take the derivative with respect to x. That's what implicit means, right? Whenever you see a y, it means f of x. So I take the derivative of this, 1 over x. I take the derivative of this, 1 over y prime. And then I take the derivative of this, so that gives me 1 over ln of 3, right, times this function, then times the derivative of arc sine, which is 1 over the square root of 1 minus the angle squared, and then times the derivative of the angle. Okay, so now we're going to enter the area where we have, and I've written it here formally, but this is where we're going to be taking the derivative of functions to functions, because we know we have a rule for like x cubed, right? That's the power rule, squared there. And we know we have a rule for like 3 to the x ln of 3, right? But in both cases, there's a number, right? There's a number here and there's a number here. This is when there's no numbers for both functions. So our first step is to take the ln of both sides. Then bring the x down in the front. Then take the derivative with respect to x. So you're going to have implicit on this side. And on this side, you're always going to have product rule. So you go do it, and then you multiply by y, and then the very last step is you put what y is equal to back into the problem. Okay, so I have to say, most people make mistakes on the first step, so be really careful. So ln of y, and then just write ln, and then just carry this along. Now bring the x down in front. X ln of cosine of x. And you know how frustrating it is if you get no points because you did the first step wrong. So take the time to just write ln and then bring the x down in front. Okay, so now we're going to take the derivative with respect to x. So I get 1 over y prime. And here I'm going to have product rule. You're expecting it. First d second plus second d first. So then I'm going to multiply by y. So let me bring it up here. So y prime equals, and I'm just going to write this term here just in a shorter way, negative x tangent of x. Not necessary, but less to write. And then the very, very last step is to put what y is equal to back in. So y prime will be cosine of x to the x times negative x tangent plus ln of cosine. Okay, last one. So you're going to have to recognize that log diff is necessary, logarithmic differentiation. So take ln of secant of x to the tangent. Again, take the time to do this step. Then bring the ln, or the tangent, down. Now take the derivative with respect to x on both sides. 1 over y prime. Expecting the product rule. First d second secant tangent plus second d first. Okay, so then we're going to multiply through by y. So let me make some room up here. So I multiply by y, so I get y prime is, so I see these two go away, right? So I get tangent squared, and then this plus ln of secant times secant squared. Oops, that's a times. Oops, and I forgot to put the y there, didn't I? Okay, equals y times. Then the very last step is to replace y with what the function was equal to, right? So y prime equals secant of x to the tangent of x, tangent squared x plus ln of secant times secant squared x. And that's it.